Hi guys, happy Friday. I hope your day is off to a really good start so far. The weekend is coming. All right, so you guys should have the notes for today. And you guys had homework last night. I have answers on here, but I'm going to send them out to you this afternoon so you can check. So I'm going to kind of skip through that slide today. You can just check them this weekend. Just a reminder, Math League is going to be this coming Tuesday. Um, it's going to be in my room. That's one of my, I'm one of the classrooms that's hosting this Tuesday. So put it on your calendar. Try to come if you can. Last time, I don't think anyone was able to go. And the time before, I had a couple people that scored the highest of everyone that did it. So I want to encourage you guys to go. You get extra points on your next test if you do. Okay, so we are going to do applications of trig functions today. Here's these homework answers that I'm just going to kind of skip through and I'll send them out to you guys. So we're going to apply what we know about the trig ratios. So first, before we do that, we got to know a little bit about some angles that are created in these scenarios that we're looking at. So we've got elevation versus depression, okay? So an angle of elevation is going to be the angle that is created by a line of sight when you're looking up from a horizontal ground, okay? So if you look at the example, if you were standing on the ground looking up at the butterfly, the angle of elevation is that angle that would be created from the line of sight looking up towards the butterfly. The angle of depression would be if you were looking down. It'll kind of make sense when you see another picture of how this could possibly work. Like maybe if you were standing on a cliff looking down at something or looking over the edge of something. I've got another picture and it'll make a little bit more sense there too. So in the diagram below, X marks the angle of elevation of the top of the tree as seen from a point on the ground. It is always inside of a triangle. Okay, so this value X is always going to be inside. If you're looking up, it's always going to be inside of your triangle. All right, in this next one, we've got this lighthouse. This is what I'm talking about. It's a little easier to see. So if you were sitting in the top of this lighthouse and you were looking down at this boat, an angle of depression is going to be created here at X. It is always going to be outside of your triangle that you draw. Okay. This value here doesn't do a whole lot for me, but maybe if you're looking at the ground and this horizontal line and this line from the lighthouse to the boat, you might notice something there. Does anyone see two parallel lines that are cut by a transversal? And there's something that we know that's really important, right? That this might create some special kind of angles in there. I'm making that thing go all over the place, sorry. All right, so how does it work? So why does it appear that there's the angle of elevation and the angle of depression are really the same? Because they kind of are, alternate interior angles. Okay, so alternate interior angles are formed when you have parallel lines that are cut by transversals. Okay, and we know that when you have a transversal line that cuts two parallel lines, the alternate interior angles are always going to be congruent. Okay, so angles of depression and angles of elevation are going to be congruent because of how they fall with horizontal lines and parallel lines. Okay. All right, so how are we going to do this? So I've got some steps for you. So step one, you're going to draw a picture, and specifically a picture of a right triangle. Okay. You're going to label the parts that you know, and then you are going to set up the trig ratio and solve. Okay, I'll give you just a second to get those things written down. Alrighty, so let's flip over and let's try some. Alright, so a tree casts a shadow 21 meters long. The angle of elevation of the sun is 51 degrees. What is the height of the tree? Okay, so I'm going to draw a picture. That's going to be the easiest thing. Okay, so I'm going to draw me a tree right here. Put him green. All right, so the shadow that the tree casts is 21 meters long. We know shadows run horizontally, right? So there's my shadow. I know this is 21 meters long, okay? So the sun is creating an angle of elevation that gives you 51 degrees. So the sun's kind of like somewhere up here, right? Okay. And it's creating this angle of elevation that's going to give you a 51 degree angle. Okay, that's going to put that down here. So if you look up to the sun, angle of elevation is inside the triangle. Looking up towards the sun, 51 degree angle. So I want to know, how tall is the tree? Boom. That's the height of the tree, right? So I'm going to look. Okay, what do I see? I've got this 51 degrees. So in relation to this, what do I have? So 21 compared to this angle, this is the adjacent side. X is the opposite side, right? So what trig function uses opposite and adjacent sides? Tangent, that's right. Okay, so what I have is tangent 51 degrees equals x over 21. This looks like things that you guys did yesterday in class, right? So we could maybe multiply by 21 on both sides. Okay, you end up with 21 times tangent 51 degrees equals x. You can plug this straight into your calculator. Okay, so you can literally type 21 times tangent 51 degrees and it's going to spit out the answer for you. Okay, so go ahead and type that in now. Should get 25.93 meters. And really we should say approximately because we're rounding. So we want to round to 2 decimal places. You guys need to make sure that you all have calculators. Okay, I didn't really say that at the beginning. So if we need to pause right now and get calculators, everybody needs to get a calculator. All right, number 2. A ladder 5 meters long leans against a vertical wall and makes a 65-degree angle with the ground. All right, so that's what I need to know right there. I have a ladder leaning against a wall. Okay, so I'm going to draw a picture. Here's my wall, and I have this ladder that's leaning against it, and it's making a 65-degree angle with the ground. So if this is my ground, I've got a 65-degree angle here, and I know I've got this right triangle. I want to know how far is the foot of the ladder from the wall. The foot of the ladder is here. So I want to know this distance here. And what else do I know? I know that the ladder is 5 meters long, right? So I know that's 5 meters. I have a really pretty, a better picture over here. We'll pull that one up after this. So if I look, I've got 65 degrees. I want to know what's the relationship with x and 5 to 65. Well, 5 is the hypotenuse, right? X is the adjacent angle. So which trig function uses adjacent, hypotenuse, the adjacent leg and the hypotenuse? Cosine. All right, so cosine of my angle, which is 65 degrees, equals x over 5. I'm trying to solve for x, so I can multiply both sides by 5. That gives me 5 times cosine of 65 degrees equals x. And again, you can plug this straight into your calculator. Okay, so plug that in. 5 times cosine of 65 degrees. You should get x is approximately equal to 2.11 meters. That represents how far this ladder is from the ground, or from the wall, I'm sorry. Okay, so here's this prettier picture, a prettier demonstration of a ladder leaning up against a building. Okay. So number 3, a small airplane climbs at an angle of 18 degrees with the ground. Find the horizontal distance that it has flown when it has reached an altitude of 800 meters. Okay, so here's my ground. Okay, I've got this plane that's taken off and it's flying. Okay, and it's here. Okay, I want to know the horizontal distance when it's at an altitude of 800. Altitude is height, right? Okay, I want to know, and it climbs at an angle of 18 degrees. So if it's climbing at an angle of 18 degrees, that's here. I want to know the horizontal distance. That would be the distance of the ground. So I go here. Okay, so I'm not looking at the 90-degree angle. I'm looking at this angle. So what are the relationships there? So I've got the opposite leg and I have the adjacent leg. Okay, so when I have opposite and adjacent, that is tangent. So I'm looking at tangent of 18 degrees equals 800 over x. Okay, so this is a little bit different. Now I have this x in the denominator. You could take tangent of 18 degrees, put it over 1 and cross multiply, or just multiply both sides by x. You get x times tangent of 18 degrees equals 800, and then come back and divide both sides by tangent of 18 degrees. So x is equal to 800 divided by tangent of 18 degrees. Even though that looks different than what you've been doing, you can still plug that straight into your calculator. Okay, so do 800 divided by tangent of 18 degrees, and it's going to give you the value. So x is approximately equal to 2,462.15 meters. That's how far it has flown horizontally. Okay, let's see what this picture looks like. See, their plane's prettier. All right, number 4. You're looking at a painting on the wall at the High Museum in Atlanta. You are standing 10 feet from the wall. Your angle of elevation to view the painting is 20 degrees. Your eyes are about 5 feet above the floor. Find how high the top of the painting is from the floor. Okay, so this one's kind of complicated, so we got to just think for a second. So you're looking at a painting on the wall. You're standing 10 feet from the wall, okay? So you know that your distance of where you are is 10 feet from the wall. So I'm going to draw, oh, I got to get my pen. So I know if I'm standing here, if this is my wall, I know that this distance is a total of 10 feet, okay? Your angle of elevation to view the painting is 20 degrees. So if you're looking from here up, your angle of elevation is 20 degrees, okay? Your eyes are about 5 feet above the floor. So it's like you're standing right here, right? There's your eyes looking up, and the ground is going to be somewhere down here, right? And we know this distance from here to your eyes is going to be 5 feet, right? That's what that's saying. All right, let me see if I can get that to go back straight. Okay. All righty, so it wants to know how high the top of the painting is from the floor. So if this is my painting up here, I need to figure out how high this is first, right? So if this is a right angle, I know 10 feet, I know X, I know 20. This is the opposite leg. This is the adjacent leg. Do you guys see what I've done here in this picture? Because it can be a little bit confusing. Your eyes are creating the angle of elevation, so you've got this triangle that you've almost created that's parallel to the floor, that's like 5 feet above the floor. Okay, so when you try to find the distance that the painting is above the floor, you can find the distance from the painting to eye level, right? And then you're going to have to also throw in, you got to remember this distance of 5 feet later on. But right now I need to just figure out what X is. Okay, so I use the triangle that I drew. So if I've got the opposite and the adjacent leg, I know that's tangent. So I have tangent of 20 degrees is x over 10. Okay. We can multiply both sides by 10. I have left out my equal sign. I'm sorry, guys. I can multiply, let me fix it. I can multiply both sides by 10. Okay. That would give me 10 times tangent of 20 degrees equals x. And you can plug that straight into your calculator. Okay. So when you plug that in, you end up getting that x is approximately 3.64. Okay, that's only the distance from eyesight to the picture. We need to remember that my eyesight is also 5 feet from the ground. Okay, it's like how it's basically saying the person is about 5 feet tall, probably a little taller than that, but you got to throw back in that height. So the distance from the painting to the top of the floor is actually going to be 3.64 plus the 5 feet for the body, right? For the person. So it's 8.64 feet. That's the distance from the bottom of the ground to the top of the picture. Okay, so let's see how this picture looks compared to mine. There we go. A little bit easier to see there. All right, so number 5. A little boy is flying a kite. The string of the kite makes an angle of 30 degrees with the ground. If the kite is 9 meters in the air, find the length in meters of the string the boy used. Okay, so I know I've got the ground, okay, and I know I have this kite up here, okay? I know that the string of the kite is making a 30-degree angle with the ground. So it's like the string's coming from here, and it's making a 30-degree angle with the ground, okay? If the kite is 9 meters in the air, so the height is 9 meters. If it's 9 meters in the air, find the length of the string, okay? So my string's going to be over here. So that's it. I've labeled everything that I know. If I have 30-degree angle, I want to figure out what x and 9 are in the triangle. Okay, so x is going to be the opposite leg, or excuse me, 9 is the opposite leg. X is the hypotenuse. So I'm looking at O and H. So we know that goes with sine. Okay, so I'm going to plug in. So sine of 30 degrees equals 9 over x. Okay. All right, so I can use these trig functions here. Okay. I'm going to go ahead and do this for this one, and then I want to see if you guys recognized anything special here. All right, so we would multiply both sides by x. We get x times sine of 30 equals 9. Come back, divide by sine of 30 degrees. And you should get that, you plug that straight in, and you should end up getting x is 18 meters. Okay, when you plug 9 divided by sine of 30 degrees in your calculator. Okay, did anyone notice when we drew this triangle, did anyone notice anything special? We created a right triangle, and the angle that was made by the tail of the kite was 30 degrees. Did anyone have something resounding in your head going, oh, I know that, that's a special right triangle? What kind of triangle did we draw? If we have a 30-degree angle and a 90-degree angle, what do I know has to be true about this angle up here? Has to be 60 degrees. Okay, so here's the other way you could do this. If you recognize, which I hope that you do, I hope you recognize when you have 30, 60, 90-degree triangles like this, that you know these properties because it saves you a lot of time. If I know the measure across from the 30-degree angle, I know that's the smallest side length, right? That's like the x. What do you know about this side over here? It's 2 times x, right? So if the small side is 9, that means that this side has to be 2 times 9, which is 18. So I could have solved for x, the hypotenuse here, simply by doing 2 times 9 because I remembered the properties of a 30, 60, 90 degree triangle, and then I don't have to do all of this work over here. If you do all of this work, it's okay. It just saves you a little bit of time if you recognize that you have a 30, 60, 90 degree triangle. Okay? Number 6. An operator at the top of a lighthouse spots a sailboat, or sights a sailboat. The point from which the sighting is made is 24 meters above sea level. The angle of depression of the sighting is 10 degrees. How far is the boat from the base of the lighthouse? All right, so I'm going to draw a little picture over here because I think you guys need to see. So you got this lighthouse right here. All right, they're usually like red and white, so I'm just going to make mine striped so it kind of looks like a lighthouse. Okay, I know that. Anyways, you get the idea. So I've got this lighthouse, and the operator spots a boat out here. Here's my boat. I'm not an artist. So there's my boat, okay? I know that the point from which the sighting is made is 24 meters above sea level, okay? So it's kind of like, here's sea level, right? This, where the sighting was made, there's a person sitting up here. We know this is 24 meters. Okay, it says the angle of depression. Remember what we said about the angle of depression? The angle of depression is always found outside of the triangle. So basically, I'm going to have this triangle that's created right here with the line of sight looking down. And the angle of depression is actually found here. So the angle of depression is 10. So if I know the angle of depression is 10, then I can automatically know the angle here. Alternate interiors are congruent, so I get 10 degrees, and I have this right triangle. Okay, so now I am just going to figure out what trig ratio I'm using. So if I have 10 degrees, oh, I'm sorry, how far is the boat from the base? So I'm looking for the distance here, right? The distance of the boat to the base of the lighthouse. All right, so I know the opposite side. I know the adjacent side. So what goes with opposite and adjacent? Tangent, right? Okay, so I have tangent of 10 degrees equals opposite over adjacent, 24 over x. Okay, so I'm going to multiply both sides by x again, and I get x times tangent of 10 degrees equals 24, and we need to divide by tangent of 10 degrees. Okay, so we see these go away, and what are we left with? Right, so you should get 136.11 meters. Okay, and the last one, number 7. A guy wire reaches from the top of a 120-meter television transmitter tower to the ground. The wire makes a 63-degree angle with the ground. Find the length of the guy wire. All right, so I have this tower, and I have a wire that's making a 63-degree angle with the ground. So I've got this wire running down to the ground. Here's my ground, right angle. The tower was 120 meters, and it's making a 63-degree angle with the ground. Find the length of the wire. So the length of the wire is here. Okay, so remember we're using the 63-degree angle. All right, I know the opposite side and I know the hypotenuse. So opposite hypotenuse, that's sine. So I set this up. I get sine of 63 degrees equals 120 over x. Have you guys started to notice something when your x is in the denominator? Have you noticed what's going to end up happening when you solve for x? You're always going to end up with the value here divided by the value here. So like this is going to end up being x is equal to 120 divided by sine of 63 degrees. Okay, you can just go straight there. But if you need to write it all out and say, okay, this is multiply both sides by x, sine of x times sine of 63 degrees equals 120. And then we would come back and divide by sine of 63 degrees. Those go away, right? X is approximately 120 divided by sine of 63 degrees. Okay, so you plug that straight in and you should get 134.68 meters. And that's the length of the wire. Okay? All right. So you guys have a worksheet to do for your homework this weekend, so you should have time in class to start working on it now. You're going to get a quiz review on Monday, and then you guys will have a quiz on Tuesday. I hope you have a great weekend, and I hope you have a great day today.